then y plus y. Okay, so in this episode, we shall be looking at the preparation for the grade 12 June 2026 Technical Mathematics Paper 2. Okay, so here we have 11 questions that we need to work with. And then all questions need to be answered. And just as the normal instructions are. Okay, let's see. Let's just dive into the question. So question 1, they're telling us that triangle PQR is right angled at P, meaning that this is a 90. Okay, so that says P at 2, 6, Q negative 1, 2, and then R will be 6 and K are given. PQ is extended to form the theta at P. Then complete the following. So when lines are perpendicular, the product of the gradient is negative 1. They want us to get the value of K. So meaning that we can use the gradient of, let's say, gradient of PR multiplied by the gradient of PQ should give us negative 1. So we know that gradient is obtained by changing Y over changing X. So I'll say PR is going to be K minus 6 over 6 minus 2 times 6 minus 2 over 2 minus minus 1 should give us negative 1. So I'll keep the K minus 6 intact over 4 times, this is going to be 4 over 3 is negative 1. I can cancel this 4 and the 4 and then multiply either side by 3. So that K minus 6 is equal to negative 3. Move this one that side, K becomes a positive 3. So that's what I'm getting with the value of K. All right. And then 1.3, they want us to get the coordinates of S such that QPRS is a rectangle. Now, if PQRS is a rectangle, one thing we need to know, one thing we need to remember is about the diagonals that bisect each other. If S is X and Y, the midpoint of QR should be the same as the midpoint of PS. So for 4 marks, let me start by getting the midpoint of PS. It's going to be X plus X1 over 2, and then Y plus Y1 over 2, which is 2. Now I'm finding the midpoint of QR first. It's going to be negative 1 plus 6 over 2, and then it's going to be 2 plus the K, we said is a 3 over 2. So that's going to be 5 over 2. It's going to be 5 over 2. So 5 over 2 and 5 over 2. Then I'll equate it to the midpoint of PS, meaning that 2 plus X over 2 should give us 5 over 2. And then 6 plus Y over 2 must also give us 5 over 2. These 2 cancels that 2, move the 2 that side, meaning that X is a 3. These 2 cancels the 2. When you move the 6, Y is a negative 1, meaning that S is basically 3 and negative 1. Okay, so that is how I would have obtained that. And then 1.4, they want us to get the angle of inclination. So with the angle of inclination, the formula is simple. We normally use gradient is equal to the tan of theta. So the theta must be the arctan of the gradient. So what is the gradient of this? So if we get the 6 minus 2 over 2 minus minus 1, it becomes a 4 over 3. We saw it here. So if I get the shift tan of 4 over 3, if I punch this in the calculator, I'm getting a 53.13 degrees. Okay, and then 1.5, we want the equation of the line that's parallel to PT So we see the gradient of this line, which I'll call as R. I don't know. Should be just the same. Or whichever point is going to be 4/3. Then y minus y1 is equal to m into x minus x1. So we know that point R is the one with 6 and 3. Let's substitute. Y minus 3 is equal to 4/3 into x minus 6. Open up. So 4/3x minus, that's going to be 4/3 times 6, which is going to be 8. No? We are plusing a 3. So 4/3x minus 5 becomes the answer of interest. Okay, then question number 2. Diagram below shows a circle with the equation x squared plus y squared. The contact point of the tangent on the circle is -3 and 1. Write down the radius of the circle. Now, one thing we need to know is that the general equation of the circle is given as, this is y. So this radius, but this is radius squared. No? So r squared is 10. Let's find the square root, meaning that the radius is just the root of 10. Okay. And then determine the equation of the tangent to the circle in this form. So if this is 0, 0, we can get a gradient here and then use the perpendicular lines of the radius. So gradient of the tangent is just going to be +3. And then y minus y1 is equal to m into x minus x1. So y minus 1 is equal to the gradient, which is 3x minus 3. We open this up, 3x plus 9. When you move this one that side, it's going to be 3x plus 10. Okay, so the equation I'm having is y is equal to 3x plus 10. And then 2.1.3, give the equation of the semicircle. Okay. If the y is between 0 and √10, positive. So in other words, if it's just in between here, is a semicircle that is drawn somewhere there. Okay, so all we have to do is just get that equation, and then what will it become? It should be y is equal to 10 minus x squared under the square root. Okay, y is equal to, okay, how do we do this? Remember, from the equation of the circle, x squared plus y squared is equal to 10. Let's make y the subject. That's 10 minus x squared, and then you find the square root. That's how we've obtained that 10 minus x squared is equal to that. And then 2.2, they want us to sketch this ellipse clearly. Okay. So that is our y, this is our x. Forgive my drawing, but yeah. So if this is 64, the square root of 64 is going to be 8. So -8, +8. And then square root of 25 is 5. So it's going to be a 5 at the top, and then -5 at the bottom. And then we just connect this. So if you're given a grid, I think it will even be better because you get more of a perfect shape. In this case, I don't have any grid, but this is how it should kind of look like. All right, then question number 3, in the diagram below, S is x -3 and OS is 5 units. Okay, we told us this is 5. First things first, they want us to determine without a calculator the value of x. So if I'm to complete this, that's a 90. This is going to be x, this is going to be -3. You can use the theorem of Pythagoras, whereby we say that x squared plus y squared equals to r squared. Now our r, which is the radius, is 5, so it's 5 squared is equal to x squared, which I don't know, -3 squared. So x will be the square root of 25 minus 9, which is 16. So x is a plus or minus 4. But since x is on the negative side of the x-axis, so meaning that x should be just a -4. Then they want us to get the cos of theta. So from here, we say cos is adjacent over hypotenuse. It's -4 over 5. And then 2, we are looking at the cosec 180 minus. So cosec is just the same as 1 over the sine. 180 minus, we know that sine is going to be positive. So it's sine of theta. And we know that the cosec of theta is the same as hypotenuse over the opposite. So the hypotenuse is a 5. The opposite is a -3. So 5 over -3 comes the answer. Then 3 point, determine the values of x if 3 sine 2x is equal to, okay, 1,465 between 0 to 360. Okay, so we're solving a trig equation. Start by dividing both sides by 3. Okay, meaning that the sine 2x is going to be 0,4883 and continuing. Then my twice x should be the shift sign of 0,4883. What does this give us? It's giving us a reference angle of 29,23 degrees. Now this is in quadrant number 1, where sine is positive. The other quadrant where sine is positive is quadrant number 2, okay, where it's going to be 180 minus the 29, something. Okay, so what will that become? They said solve for x. Okay? So 180 minus, okay, let's just start by doing this. And then 180 minus 29, it should be a 150 something. It's 150,77. Then divide by 2 for the first one. It's going to be a 14,62. And then in this other case, going to be a 75,38 degrees. So that is how we would have worked out 3.2. Question number 4, they want us to simplify this trig. Okay, so with reductions. Let me just write it on this other side, maybe to make a lot of sense. Okay, so they're telling us that if we have the tan of 180 minus theta, we're multiplying by the cot of 360 minus theta, we are subtracting sine squared of 180 plus theta. All this is over the sec of 180 minus theta multiplied by the sec of theta plus the tan squared of theta. Okay, so let's see how we reduce this. So all the angles are in the right formats. So tan 180, that's quadrant number 2. We're gonna get a negative tan theta. Okay. And then the cot of 360, cot is a reciprocal of tan. Tan in the fourth quadrant is negative. meaning that's negative cot of theta. Then we are subtracting sine squared 180 plus. So in this case, 180 is in the third quadrant. The sign is going to be negative, but since you're squaring, it will remain as a positive. We are dividing by 180 minus is in the second quadrant. Sec is the reciprocal of cos. Cos is negative there, so negative sec theta. We are multiplying by just the sec theta, and then we are adding the tan squared theta. Okay. So what we notice is that we need to cancel out what is at the top or what is at the bottom and simplify whatever we need to simplify. So this cot is the same as 1 over 10, meaning that this and this is going to cancel out. Okay. Oh, okay, it's fine. Let me just write it out nicely. Tan theta, it will be positive. This is 1 over 10 minus the sine squared over sec, and sec is going to give me sec squared, but let me rearrange it around and say it's the tan squared minus the sec squared. So this and that we say is going to be a 1. So 1 minus sine squared theta over the tan squared minus the sec squared. What does it give us? Let's look at it this way. If this is sine squared over the cos squared, you're subtracting sec, which is 1 over cos. If you do your cross multiplication, if we do our cross multiplication, tan squared minus sec squared. Okay, it's gonna be sine squared theta, cos squared theta minus the cos squared theta over, this is cos squared theta. Okay, no, let's just do it because we're seeing it's the same denominator, no? So we don't need to cross multiply, just say sine squared theta minus 1 over cos squared theta. So we know that sine squared minus 1 is the same as 1 minus sine squared if we introduce a negative, which is going to give us the cos squared. Ne? So it will be cos squared over cos squared, which is going to be 1. So I'll say this is a negative 1. So on top, we're going to have a cos squared theta over negative 1, meaning that our answer is a negative cos squared theta. Okay. Then can we prove that this is the same as negative 1? Let's see if we can do that. So we have sine x. We are dividing it by negative cosec x. We are adding cos squared x and then multiplying by the tan x all over the tan of 180 plus x. Okay, so we know that 1 over sine gives us cosec, so I'm going to take this thing back so that it is sine x multiplied by the sine x plus that's cos squared x, which is sine x over cos x. We are dividing by, when we reduce this, we're only going to get the tan x. Why did I even divide? I'm supposed to cancel this. Okay, let's just cancel that and that together. Okay, then we have, this is going to be negative sine squared x plus the cos squared x. Something doesn't add up. What did I do wrong? Please cancel this. That was a plus. This is a negative. Oh, the answer is negative 1. Okay, it makes sense there. Does it? Doesn't. It doesn't make sense. we said cos squared times tan x. This is tan minus, not plus. Meaning that this is a negative, then this should be negative. Yeah, then it should make sense. So take out the negative, we're going to be left with sine squared x plus the cos squared x, which is a -1, which is equal to the right-hand side. Okay. Then now we move on to question number 5. Given the functions defined by tan x minus 1, cos 2x, between 0 and 360, okay, then they want us to sketch on the same set of axes. So what I'm going to do, I can, okay, let's just plot it this side. Between 0 to 360, okay. So that the x, this is the 0. Let me use steps of, I think 45 will be fair enough. So 45, 90, 135, 180, 225, 270, 135. Oh, why are you going to 135 again? It's 315. And then 360. And then when I look at my functions, we have tan x minus 1. The other one is cos 2x, meaning that the highest point the graphs can reach is just the 1. But just to cater for the tan, I'll just get it up until 2. So 1 and 2, -1, and then -2. Okay, so all I'll do is punch this into my calculator. Okay, using the table method. And then from there, I'll just do the plotting. Okay, so when they ask for the start, we're starting from 0 and we are ending at 360. The step, I'm using 45. So if I start with the tan 1 minus x, okay, I have an asymptote at 90. I also have an asymptote at 270. And that is for the tan. Then, when x is a 0, I'm getting a -1. When x is 45, that's 1 minus 1 is a 0. So meaning this graph should just be moving in this sort of direction. Okay. And then when x is 135, we are getting somewhere around 32. When x is 180, I'm ending up with just a -1, subtracting 225 is a 0, and then it should move towards the 270. Okay. Then next, if x is 315, I'm getting a -2 down there. And then 360, it should be a -1. Meaning that we have something like that towards the asymptote. Okay, so that is the tan graph. Let's go to the cos. Okay, so cos of 0 is going to be a 1. And then the 45, that's going to be 45 by 2, which is 90, which must give us a 0. So 90 by 2, 180 gives us a -1. Okay. And then 135. Okay, so we're done with the sketching. Then the next question is going to ask for the period of G. So when you look at G, the normal period of a cos graph is 360, but since we have a 2, it's going to be 360 divided by 2, which is 180. And then give the equation of h if f is moved 3 units up. What are we moving? We are moving f 3 units up, meaning that h of x is going to be the tan of x plus 2, because it's going to be -1 plus 3 becomes +2. Then 5.4, use your graph to determine the following. Okay, if we have the cos of x, cos of 2x plus 1 is less or equal to tan of x. So let's move this one to that side so that we have the cos 2x is less or equal to the tan x minus 1. So where do we find the graph of cos to be under the graph of tan? The graph of cos to be under. So I'm looking at 45, okay, up to something like a 90. That's when it is under. After 90, it's above. So 45 and 90, I'll represent it as 45 less x less 90, or we have equal signs now. Then the other section where the graph is below is between 225 and 270. So 225 is less or equal to x less or equal to 270. Then where do you find the g of x to be below 0? G of x to be below 0 is between 45 and 135, and then 225 and 315. Okay, so 45 is less x is less 135, and then we said that it is 225 to 315. All right, then question number 6. We are given this drawing, A, B, C, D. Then they want us to find the cosine rule for triangle A, B, C. Cosine rule for triangle A, B, C. So remember, cosine rule can be in different formats depending on which angle that you are looking at. So if I focus on angle C, meaning that our opposite side is AB, so I'll say that it is AB squared is equal to AC squared plus BC squared minus twice AC times BC, the cos of C. Okay, so that is the cosine rule. Then calculate the length of DB, this one, correct 1 decimal place. Okay, so we have this. So we need to find this angle D first. Then we can apply the sine rule. Okay, so if I have D plus 38 plus 87 should give me 180. Is that correct? Then our D is going to be 180 minus the 125, which should give me 55. So I'm going to say that DB over the sine of 38 should give me the AB, which is a 7, over the sine of 55. So our DB is going to be 7 sine 38 over sine of 55. Now I punch this into the calculator to 1 decimal place. I'm getting a 5.3 units. Then they want the size of CAB. CAB for 3 marks, which means we're going to have to use the cosine rule. Okay, so if this is what we have, and then we can say that the CB squared, which is going to be 8 squared, should be equivalent to the 5 squared plus the 7 squared minus 2 times 7 times 5, the cos of the CAB that we want. So when you play around with all of this, because that's 64 minus 25 minus 49, and then divide by the negative 70, I'm ending up with the 1/7. Okay, so the cos of A is 1/7, and then the shift cos of that. So the arc cos of 1/7 is 81,79. Then determine the area of ABC. Now, since we have this angle as 81,79, then we're going to use these two sides using the area rule. So it's a half multiplied by the AC multiplied by the AB, and then the sine of A. So it's a half times 5 times 7, the sine of 81,79. That gives me 17,49. That's units squared. And then 6.5, the one the shortest distance between C and the line AB. So meaning that the shortest distance should be making a 90-degree, okay, if ever we are to look at it in that format. So we know that a half of AB is going to give us 3,5. Okay, maybe we can start from there. Half of AB is 3,5 units. Then, since the question is asking for the length of this bisector, we can use the cosine rule. So that's a 3,5, 5, and 81. Then we can get what we need. So how are you going to do that? Let's just substitute and say that our bisector, which is, I'll call it T, is equivalent to the 5 squared plus the 3,5 squared minus 2 times 5 times 3,5, the cos of 81,79. So T will be the square root of everything that is here. Okay, let's not waste time. Meaning that T, let me just punch everything in the calculator. I get 5,68 units. All right, then question number 7 in the diagram below. O is the center of the circle. AB is a 24. It means this is a 12, that's also 12. M is the midpoint of AD. MD is 8. Let OM be X. Okay. They want us to write down the length of AM. That's going to be 12 centimeters. We don't need the reason. Reason should be bisected. That's a midpoint. Then write down the length of OD in terms of X. So OD is going to be X plus 8 because we're adding these two. And then can we give a reason why OA? Okay, so start by telling us that OM is perpendicular to AB. Reason being, line from the center to the midpoint of a chord must be perpendicular. So if that's a 90, let's use the Pythagoras to focus on OAM or OMA. So meaning that our OA is going to be the 12 squared plus the 8 squared. Let's say OA squared, which is going to be 144 plus X squared should be OA squared. But we said OA is the same as OD. So OD is going to be X plus 8. Okay. And then if we square this and we square that, and then equate the two, it simply means that 144 plus X squared is equal to, that's going to be X squared plus 16X plus a 64. The X squared and X squared will fall away, okay, meaning that 144 is the same as 16X plus 64. I move the 6 for that side. I'm going to be left with 80. Divide both sides by 16, x becomes 5. But the question is not asking for x. They're asking for the length of the radius. So if this is 5, meaning that our OD, which is the same as OA, is going to be 8 plus 5, which is 13 centimeters. Okay, so that is how we get the length in that triangle, the 13. Wait a minute, did I do the right thing? I've answered both questions same time. Okay, all right. Because they say they want the length of OA in terms of x, which is this name, which we are done with. So that was 7.4. And then 7.5 goes up to this point of 13. All right, then can we give the value of the radius? We've already answered it also, because we said it's 13. All right, guys, so that is question number 7. Then question number 8, in the diagram below, AC is a chord with O, D2 is 50, A2 is a 30, and then BD is a diameter. Can we give reasons? Okay, the size of D1. So we're seeing that A2 and D1 are in the same segment. Okay, so D1 is going to be a 30. Okay, so we're saying D1 is in a semicircle. You can see that. Okay, then C1, this angle here, is the same as the 50 here, because it will be angles in the same segment also. So C1 is a 50 angle in the same segment. And then they want us to get C2. So still the same story. This is a 90, which means that's going to be 40. So we're saying C2 is a 40 angle in a semicircle. And then they want us to get B1. B1. So when you look at B1, it should be the same as the 40 angles in the same segment. Okay, so B1 is a 40 angles in the same segment. And then lastly, they want us to get B2. Okay, so if this is a 50, this is a 30, we can find B2 using the angles in the triangle ABC, or we can also look at the whole of B and the whole of D to be the opposite angles of a cyclic quad, whichever one. So if I look at a 30 plus 50 plus 40 plus B2 should give us 180 angles in a triangle. This is 80, 120. Okay, so B2 is going to be 180 minus 120, which is 60 degrees. All right, then question number 9. We're being told that in the diagram below, PV is 24 centimeters. VR is a 22 centimeters. ST is a 12, and then PQ is parallel to VS, and then PS is parallel to VT. Can we determine the length of TR? So you can use the ratios and say that if we have the TR over the TS, it should be the same as VR over the VP. This is the proportionality theorem. VT is parallel to PS. Our TR is what we need, which is going to be the VR, which is a 22, times the TS, which is a 12, over the VP, which is a 24. So TR becomes 11 centimeters, because by 12 is 1, by 12 is 2. 22 over 2 is 11. Okay, if that is true, they want us to get the length of QR, meaning that from here up to there. So you can look at which lines are you going to focus on? We're going to focus on these two parallel lines, okay? And see that if we have SR over QR, it should be the same as VR over PR. Same reason, proportionality theorem, because PQ is parallel to VS. So our SR is 12 and 11, which is a 23 over QR, which I don't know. It's equivalent to VR, which is a 22 over, this is gonna be 46. Then cross multiply, and let's see what we end up with. So 23 times a 46 divided by a 22. That should be our QR, okay? And when we look at the calculator, remember we are looking for the QR. So that's gonna be 48.1 centimeter. And the 9.2 in the diagram below, PQRS is a parallelogram, meaning that this is parallel to this, and then this is parallel to that. Can we determine PO, okay, over OC? So how does that relate? Number one, did they give us any numbers? Yes, they gave us some ratios where they told us that QB over BR. QB over BR is 2, that is 2x. This should be 3x. Okay. Need to find a way to relate this. Okay, so if this is 5x, this is a parallelogram, then it's not gonna make sense for me. Okay, if that is 5x, meaning that looking at the lines that are parallel, it's this and that. Which means I can relate this to this. And then the whole of this is also gonna be the whole of that because diagonals bisect. Okay, so I can say that BR over QB should be the same as CR over OC. So our BR is, but why don't I just look at the whole thing? Next one, let me just break it down bit by bit. So our BR is gonna be at 3x over the QB, which is 2x, is equal to CR over OC, which means it's 3 over 2. Okay, so let me also, it's telling us CR is a 3. This is a 2. We're saying that is x and x. But then the whole of this is 5x. This is also 5x. So if I'm looking at the ratio of PO, okay, so PO over OC, our PO is a 5x over the OC, which is a 2x, which means the ratio is just going to be 5 over 2. Okay, so that is what I'm ending up with. Probably the only thing I have to state is that PO is the same as OR, diagonals of a parallelogram. Okay, question number 10. A tire of a car driving on the highway has an average rotation of 1.5 revolutions per minute. Then the tire has a diameter of 55.9 centimeters. The cartoon and diagram below represent the tire. Convert the rotations to per second. So that's going to be 1.5 divided by 60, which gives us 25 revolutions per second, which is so fast. Then determine the circumferential velocity of the tire in millimeters per second. So one thing we know about the circumferential velocity is that V, why don't I just write it up here? Say that V is pi dn. So it's a pi. Our diameter is a 55.9 centimeters, but we need to change this to millimeters. So we multiply by 10 and then multiply by the number of rotations per second, which will be 25. So this becomes 13975 pi millimeters per second. We can give it as a decimal to something like 43903.76 millimeters per second. And then 10.3, they want the angular velocity. So we know that angular velocity is given as 2 pi n, which will be 2 pi, and then the number of revolutions per second, radians. Then we need to change it to seconds, okay, which is going to be the same as 157.08. Okay, that's if we eliminate the pi and stuff. So that is what we are getting. And then 10.4, what will be the diameter of the tire if it decreased by 1/3? So if I get 1/3 of 55.9, I'm ending up with 18.63. Then I need to subtract 18.63. This gives me a 37.27. This is 10.4. And then 10.5. What would the new circumferential velocity of the tire be with a decreased diameter in centimeters per minute? Okay, circumferential velocity, we say pi dn. That's pi. The new diameter is a 37.27. And then the number of revolutions per minute, we said was 1,500. Okay, so simplifying this, we're getting 5,900 pi centimeters per minute. Change this to decimal, I'll get 175,615.03 centimeters per minute. All right, guys, so that brings us to the end. No, not really. Not really. We have question 11. Question 11, the picture and diagram below represent a lemon that was cut in half. The diameter of the lemon is 8. Okay, so from this side to that side, we have 8. And then the angle formed is approximately 42. 11.1.1. They want us to get the length of one of the arcs of the segment. The arc length, S, will be obtained by the radius multiplied by the angle. So the radius is going to be 8/2, since 8 is a diameter. And then our theta is going to be the 42 degrees. We need to change this to radians. It's pi/180. Okay, simplifying this, it's going to be 4 and 42 and all of that, which is 14/15 pi, which is 2.93 centimeters. So just this small length here is 2.93. And then determine the area of one segment. So area is given as RS divided by 2. Okay. If we do our substitution, remember we got this, so you can just replace it and say that it is 14/15 pi I'm going to multiply this by the radius, which is 4, then divide by 2. When I simplify this, I'm ending up with a 5,86 centimeters squared. Remember, the S is what we got. You can alternatively use the decimal. There's no problem with that. The answer you get will be approximately the same. And then 11.3, what will the approximate area be of all the wedges in the diagram? So how many wedges do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer we got here, 5,86 multiplied by 12. And then that should give us a 17,32 centimeters squared. 11, below is a picture of a man that's wearing circular eyeglasses. And on the right is a diagram of depicting the image. So there's a chord, AB, that is drawn through the pupil. The length of the chord is 7. And then the diameter of the glass is 10. Okay. They want us to determine the height from the pupil to the bottom of the glass. So this distance is what they want us to get. So what we can do, we can say that 4h squared minus 4dh plus h squared is equal to 0. Okay, from the ellipse kind of equation. And then we can substitute as the diameter is 10. It's going to be 4h squared minus 4 times 10 with h plus the x, which is 7. Okay, should be equivalent to 0. This gives us 4h squared minus 40h plus a 49 equals to 0. And then we can substitute this into a quadratic formula, negative b plus minus b squared minus 4ac over twice a. So plus minus, this is going to be a negative 40 squared minus 4, 4, and 49 divided by 2 and 4. So the first h I'm getting is 8,57, and then the other h is 1,43. Now, the question is asking for the biggest height, which is 8,57. Therefore, h is 8,57. All right, then 11.3, the ordinates in the regular figure are 8 centimeters, 7, 4, 5, and so on. The width of the irregular figure is 15. Okay. Question is asking us for the area of the above figure. So we know that the area of any shape that is irregular will be given as A into 1 ordinate, the ordinate n over 2, plus ordinate 2, ordinate 3. Then if we do our substitution, they are telling us that we have a total of 15. Okay, so it's going to be 15 divided by 2. Look at the, no, not 2. Divide by, how many ordinates do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 ordinates. So which means we're going to divide this by 8. And then with the first one, it's going to be 8 plus the last one is 9. Divide by 2. Second one is a 7 plus 4 plus 5 plus 9 plus 6 plus 3 plus 2. Okay, we punch this into the calculator. I'm getting 83,44 centimeters squared. All right, so that brings us to the end of this paper. And I wish you guys all the best in your preparations. Thank you and bye-bye.